The National Electrical Code Section 250.52.8.1 addresses the use of interior metal water piping as part of the grounding electrode system. A key aspect of this section is the stipulation that metal water piping located more than 1.52 meters or 5 feet from the point of entrance to the building cannot be used as a part of the grounding electrode system or as a conductor to interconnect electrodes that are part of the grounding electrode system. However, there is an exception to this rule. The exception permits the use of metal water piping beyond the 5-foot limit in industrial and commercial buildings or structures where conditions of maintenance and supervision ensure that only qualified persons service the installation. The primary reason for the 5-foot limitation is to address the potential for corrosion and other factors that can negatively impact the conductivity and overall effectiveness of the metal water piping as a grounding electrode. Beyond this distance, several factors come into play that can compromise the integrity of the piping as a reliable grounding path. Firstly, corrosion is a significant concern. Metal water pipes, especially those buried underground or exposed to moisture, are susceptible to corrosion over time. Corrosion increases the resistance of the piping, reducing its ability to effectively conduct fault current to ground. This increased resistance can impair the performance of the grounding electrode system, potentially delaying or preventing the operation of overcurrent protective devices such as circuit breakers or fuses during a fault condition. Secondly, the electrical continuity of the piping system can be affected by various factors. Joints in the piping, such as threaded connections or couplings, may loosen over time, creating points of high resistance. Non-conductive materials, such as plastic or rubber fittings, may be introduced into the piping system during repairs or modifications, further disrupting electrical continuity. The presence of these discontinuities can significantly reduce the effectiveness of the metal water piping as a grounding electrode. Thirdly, the composition of the water flowing through the pipes can also influence their conductivity. Highly mineralized water can deposit conductor scale on the interior of the pipes, potentially improving their conductivity. Conversely, corrosive water can accelerate the deterioration of the pipes, reducing their conductivity. The unpredictable nature of these effects makes it difficult to rely on metal water piping beyond the 5-foot limit as a consistent and reliable grounding electrode. The exception to the 5-foot rule for industrial and commercial buildings recognizes that in these settings, there is typically a higher level of maintenance and supervision performed by qualified personnel. Qualified persons are individuals who possess the necessary knowledge, skills, and experience to properly install, maintain, and inspect electrical systems, including grounding electrode systems. These individuals are trained to recognize potential hazards and take appropriate measures to mitigate them. Firstly, regular inspections are a critical component of maintaining the integrity of grounding electrode systems in industrial and commercial buildings. Qualified persons conduct periodic inspections of the metal water piping to identify signs of corrosion, loose connections, or other potential problems. These inspections allow for the early detection and correction of issues that could compromise the effectiveness of the grounding electrode. Secondly, qualified persons are trained to properly install and maintain metal water piping systems to ensure electrical continuity. They use appropriate bonding techniques to connect different sections of piping and ensure that all joints are tight and corrosion resistant. They also take steps to minimize the introduction of non-conductive materials into the piping system. Thirdly, qualified persons are knowledgeable about the potential hazards associated with using metal water piping as a grounding electrode. They understand the importance of maintaining the integrity of the piping and take steps to protect it from damage and corrosion. They also understand the limitations of metal water piping as a grounding electrode and may supplement it with other grounding electrodes, such as ground rods or ground plates, to provide a more robust grounding system. It is important to note that even in industrial and commercial buildings, the exception to the 5-foot rule should only be applied when there is a comprehensive program in place for maintaining and supervising the grounding electrode system. This program should include regular inspections, proper installation and maintenance practices, and ongoing training for qualified persons. Without such a program, the risks associated with using metal water piping beyond the 5-foot limit may outweigh the benefits. In summary, the 5-foot limitation on the use of interior metal water piping as a grounding electrode is intended to address the potential for corrosion, discontinuities, and other factors that can compromise its effectiveness. The exception to this rule for industrial and commercial buildings recognizes that in these settings, qualified persons can mitigate these risks through proper maintenance and supervision. However, it is essential that a comprehensive program be in place to ensure the ongoing integrity of the grounding electrode system. To further elaborate, consider the specific tasks and responsibilities that qualified persons would undertake to ensure the continued suitability of metal water piping as a grounding electrode beyond the initial 5-foot mark. One key aspect involves assessing the environment surrounding the piping. Qualified personnel would need to evaluate factors such as soil conditions, moisture levels, and the presence of corrosive substances that could accelerate the deterioration of the pipe. Based on this assessment, they could implement protective measures such as applying corrosion-resistant coatings or installing cathodic protection systems to extend the lifespan of the piping and maintain its conductivity. Another important task involves regularly testing the electrical continuity of the piping system. Qualified persons would use specialized equipment such as low-resistance ohmmeters to measure the resistance between different points in the piping. Elevated resistance readings could indicate loose connections, corrosion, or other issues that need to be addressed. The testing frequency would depend on the specific environment and the age of the piping, but it should be conducted at least annually. Furthermore, qualified personnel would be responsible for maintaining accurate records of all inspections, tests, and repairs performed in the grounding electrode system. These records would serve as a valuable resource for tracking the condition of the piping over time and identifying potential problems before they become serious. The records would also be essential for demonstrating compliance with applicable codes and standards. In addition to these technical tasks, qualified persons would also need to possess strong communication and problem-solving skills. They would need to be able to effectively communicate their findings to building owners, managers, and other stakeholders, and to work collaboratively to develop solutions to any issues that arise. They would also need to be able to troubleshoot complex electrical problems and to make informed decisions about the best course of action. The specific qualifications required for qualified persons may vary depending on local regulations and industry standards. However, in general, these individuals should possess a thorough understanding of electrical theory, grounding principles, and applicable codes and standards. They should also have extensive experience in installing, maintaining, and inspecting electrical systems. Many qualified persons hold certifications from recognized organizations such as the National Institute for Certification in Engineering Technologies or the International Association of Electrical Inspectors. These certifications demonstrate that they have met certain minimum requirements for knowledge and experience. It is also important to consider the potential consequences of failing to properly maintain the grounding electrode system. A compromised grounding system can increase the risk of electrical shock, equipment damage, and fire. In severe cases, it can even lead to fatalities. Therefore, it is essential that building owners and managers take their responsibilities for maintaining the grounding system seriously and ensure that only qualified persons are entrusted with this critical task. In conclusion, the NEC Section 250.52 8.1 reflects a careful balance between the desire to utilize readily available metal water piping as a grounding electrode and the need to ensure the safety and reliability of the electrical system. The 5-foot limitation is intended to minimize the risks associated with corrosion and other factors that can degrade the conductivity of the piping, while the exception for industrial and commercial buildings recognizes that qualified persons can mitigate these risks through proper maintenance and supervision. By understanding the rationale behind these rules and by diligently following best practices for grounding electrode system maintenance, electrical professionals can help to ensure the safety of people and property. To further illustrate the practical application of these concepts, consider a hypothetical scenario. Imagine a large manufacturing facility with extensive metal water piping running throughout the building. The facility's electrical system is grounded to the water piping at the point of entry, but some critical equipment is located more than 5 feet away from this point. Under the NEC rules, the the water piping beyond the 5-foot mark could not be used as a grounding electrode unless the facility met the requirements for the exception. To qualify for the exception, the facility's management would need to demonstrate that they have a comprehensive program in place for maintaining and supervising the grounding electrode system. This program would need to include regular inspections of the water piping, testing of the electrical continuity, and documentation of all maintenance activities. The inspections would be performed by qualified persons who have the necessary training and experience to identify potential problems. If the facility could demonstrate that it met these requirements, it would be allowed to use the water piping beyond the 5-foot mark as a grounding electrode. However, it would still need to comply with all other applicable code requirements, such as ensuring that the piping is properly bonded and that the grounding electrode system is adequately sized. Conversely, if the facility did not have a comprehensive maintenance program in place, it would not be allowed to use the water piping beyond the 5-foot mark as a grounding electrode. In this case, it would need to install additional grounding electrodes, such as ground rods or ground plates, to provide adequate grounding for the equipment. The choice between these two options would depend on a variety of factors, including the cost of installing additional grounding electrodes, the complexity of the facility's electrical system, and the level of risk that the facility is willing to accept. Ultimately, the goal is to ensure that the electrical system is properly grounded and that the risk of electrical shock, equipment damage, and fire is minimized. Another important consideration is the potential for stray current to flow through the metal water piping. Stray current can be caused by a variety of factors, including unbalanced loads, faulty wiring, and nearby electrical equipment. When stray current flows through the water piping, it can accelerate corrosion and damage the piping. In some cases, it can even create a shock hazard. To mitigate the risks associated with stray current, it is important to ensure that the electrical system is properly balanced and that all wiring is in good condition. It may also be necessary to install specialized equipment, such as ground fault circuit interrupters, to detect and interrupt stray current flow. Qualified persons can play a key role in identifying and addressing stray current problems. They can use specialized equipment to measure stray current levels and to trace the source of the current. They can also recommend and implement corrective measures to reduce or eliminate stray current flow. The National Electrical Code provides detailed requirements for grounding and bonding electrical systems. These requirements are designed to ensure that electrical systems are safe and reliable. It is essential that electrical professionals be thoroughly familiar with these requirements and that they follow them diligently. Failure to comply with the NEC can have serious consequences, including fines, lawsuits, and even criminal charges. In addition to the NEC, there may be other applicable codes and standards that need to be considered. For example, some local jurisdictions may have their own electrical codes that are more stringent than the NEC. It is important to check with the local authorities to determine which codes and standards apply in a particular area. The field of electrical safety is constantly evolving, with new technologies and new challenges emerging all the time. It is essential that electrical professionals stay up to date on the latest developments in the field and that they continue to learn and grow throughout their careers. There are many resources available to help electrical professionals stay informed, including trade publications, industry conferences, and online training courses. By investing in their professional development, electrical professionals can ensure that they are providing the highest level of safety and service to their clients. Furthermore, consider the perspective of an electrical inspector tasked with evaluating an installation. The inspector's role is to verify that the installation complies with all applicable codes and standards and that it is safe for use. When inspecting a grounding electrode system that relies on metal water piping beyond the 5-foot mark, the inspector would pay close attention to the documentation provided by the qualified person. The inspector would want to see evidence that regular inspections have been performed, that the electrical continuity of the piping has been tested, and that any necessary repairs have been made. The inspector would also want to verify that the qualified persons have the necessary training and experience to perform these tasks. If the inspector is not satisfied with the documentation or the qualifications of the personnel, the inspector may require that additional grounding electrodes be installed to supplement the water piping. The inspector's decision would be based on a careful assessment of the risks involved and the need to ensure the safety of the installation. The inspector may also use specialized equipment to verify the effectiveness of the grounding electrode system. For example, the inspector may use a ground impedance tester to measure the impedance of the grounding path. A high impedance reading could indicate a problem with the grounding electrode system, such as corrosion or loose connections. In addition to the technical aspects of the installation, the inspector would also consider the overall condition of the building and the environment surrounding the water piping. If the building is located in a corrosive environment, the inspector may be more likely to require additional grounding electrodes. The inspector's goal is to ensure that the grounding electrode system is adequate to protect the building and its occupants from electrical hazards, even under adverse conditions. Another crucial element to discuss is the concept of bonding within the electrical system. Bonding refers to the practice of connecting all metallic parts of the electrical system together to create a low impedance path for fault current to flow back to the source. This bonding helps to ensure that overcurrent protective devices, such as circuit breakers, will trip quickly in the event of a fault, minimizing the risk of electrical shock and equipment damage. The National Electrical Code provides detailed requirements for bonding, including specific rules for bonding metal water piping. These rules are designed to ensure that the water piping is effectively connected to the electrical system and that it provides a reliable grounding path. When metal water piping is used as a grounding electrode, it is essential that it be properly bonded to the electrical service equipment. This bonding is typically accomplished by connecting a bonding jumper from the service equipment to the water piping. The size of the bonding jumper must be adequate to carry the maximum fault current that could flow through the piping. In addition to bonding the water pipe into the service equipment, it is also important to bond all other metallic parts of the electrical system together, such as metal conduit, metal enclosures, and metal equipment frames. This bonding helps to create a comprehensive grounding system that provides a high level of protection against electrical hazards. Qualified persons play a key role in ensuring that electrical systems are properly bonded. They have the knowledge and skills to select the appropriate bonding methods and materials and to install them correctly. They also understand the importance of inspecting bonding connections to ensure that they are tight and corrosion resistant. In summary, the use of metal water piping as a grounding electrode is a complex issue that requires careful consideration of a variety of factors. The National Electrical Code provides detailed rules and guidelines for using water piping as a grounding electrode, and it is essential that electrical professionals be thoroughly familiar with these requirements. Qualified persons play a key role in ensuring that grounding electrode systems that rely on metal water piping are properly installed, maintained, and inspected. By following best practices for grounding and bonding, electrical professionals can help to ensure the safety of people and property. It is also essential to consider the long-term maintenance and upkeep of the grounding electrode system. Over time, even properly installed grounding electrodes can degrade due to corrosion, weathering, and other factors. Therefore, it is important to establish a regular maintenance schedule to inspect and test the grounding electrode system. The frequency of inspection should depend on the environment and the type of grounding electrodes used. However, at a minimum, grounding electrode systems should be inspected annually. During inspections, qualified persons should check for signs of corrosion, loose connections, and other problems. They should also test the resistance of the grounding electrode system to ensure that it is still within acceptable limits. If any problems are found, they should be corrected promptly to maintain the effectiveness of the grounding system. In addition to regular inspections, it may also be necessary to perform periodic maintenance on the grounding electrode system. This maintenance could include cleaning grounding electrodes, tightening connections, or replacing damaged components. The specific maintenance tasks that are required will depend on the type of grounding electrodes used and the environment in which they are located. It is also important to keep accurate records of all inspections, tests, and maintenance activities performed on the grounding electrode system. These records will provide a valuable history of the grounding system and will help to identify any potential problems early on. The records should be kept in a safe and accessible location. Finally, it is essential to remember that the grounding electrode system is only one part of a comprehensive electrical safety program. A complete program should also include regular inspections of electrical equipment, proper training for employees, and the use of personal protective equipment. By taking a holistic approach to electrical safety, businesses can minimize the risk of electrical accidents and injuries.